This lecture is about chapter 7. Okay. Chapter 7 is our one introduction into the tools that we can use to study welfare economics. Basically, here we're going to learn about consumer surplus, producer surplus, total surplus, and how a surplus can be used to measure efficiency of a market. Okay, the purpose is to introduce welfare economics. Okay, the chapter examines how the allocation of resources affect economic well-being. Let's see, talk about, concepts of consumer surplus, producer surplus. All right, so basically what we're going to do is talk about consumer surplus, spend, a third of the chapter talking about that. Producer surplus, opposite day of consumer surplus, spend about a third of the chapter talking about that. Then we're going to put them together, create something called total surplus, and then we're going to talk about how efficiency is measured and maximizing total surplus leads to a very efficient outcome. Okay. All right, let's start. Start with welfare economics. Welfare economics is the study of how the allocation of resources affect the economic well-being of the members of its society. Again, this is our basic introduction to basic tools. There are whole subfields in economics dedicated to welfare economics. I'm not a real expert in this field. But we will learn the basics in this course. Okay. All right, let's start with the consumer surplus. Consumer surplus. I'm going to use CS to denote consumer surplus. Consumer surplus is equal to the amount a buyer is willing to pay for some good or service minus the amount they actually paid. Okay. Well, the amount a consumer is willing to pay is equal to up to the value of that to the buyer. So if I value something, let's say a slice of pizza at $10, I'm willing to pay up to $10 for that slice of pizza. I will not pay more than that. Okay, I will only pay up to the $10 mark because that's how much I value it. And if I pay exactly $10, my value equals how much I paid, right? All right. The amount actually paid, okay, that is pretty easy. That's the total expenditure. And that's the actual price, okay? The amount that the buyer actually pays is the price that they paid, okay? All right, so what we're going to do is talk about this concept of consumer surplus in two ways. One with the market demand curve and one with the individual demand curve. So when we clear this, let's talk about that. All right. First, we're going to talk about the individual demand curve. Discussion of consumer surplus, individual demand curve. Okay. Well, let's just draw the individual demand curve. Here's quantity of pizza. Here's the price of pizza. Here's the demand for pizza by some person, okay? At a price of, say, $10 a slice, this person wants 0 slices of pizza. For that first slice of pizza, this person is willing to pay, I don't know, $9 a slice. $9 for that first slice. I'm sorry, just for that first slice. He's willing to pay $9. For that second slice of pizza, the person is willing to pay, I don't know, $8. For that third slice of pizza, this person, I don't want to say Bob, is willing to pay $7. However, that's not how the world works. When Bob goes to Pizza Hut doesn't charge him $9 for the first slice, $8 for the second slice, and $7 for the third slice. When Bob goes to Pizza Hut has a menu. It says, okay, look. And the menu says $5 a slice. You could buy as many slices as you want. Well, Bob, where $5 hits the demand curve, is out here. 4, 5, 6, about 7 slices. He'll buy 7 slices given his demand curve, and the price of pizza is $5. Okay. Remember, for that first slice, he was willing to pay up to $9. Okay. But he only paid $5. Okay. This was his willingness to pay. He was willing to pay. Why was he willing to pay up to $9? That's because that's how he valued it given his demand curve. He valued that first slice of pizza at $9. The demand curve provides how this person, Bob, values each slice of pizza, the marginal slice of pizza. For that first slice, he values it 9. He values it right here at 9. He paid 5. That's his actual pay. So this vertical distance right here, which is 9 minus 5, that is his consumer surplus for that first slice of pizza. Well, what about his second slice? His second slice of pizza, he was willing to pay 8, but he only paid 5. So this vertical distance is his consumer surplus for the second slice of pizza. Okay, this is his first right here. All right, what about his third slice? This guy's willing to pay 7. He paid 5. So this vertical distance of 7 minus 5, or 2, is his consumer surplus for his third slice of pizza. And we could do the same thing for his fourth, his fifth, his sixth, whatever, right? All the way down, okay, up to 7 slices. If we add up these blocks, okay, then we could figure out his total consumer surplus of eating 7 pizzas. Okay, his total consumer surplus of 7 pizzas that he bought, his 7 slices, will be equal to consumer surplus for the first slice plus consumer surplus for the second slice plus consumer surplus for the third slice. Keep going down. First slice was 9 minus 5, or 4. Second slice was 8 minus 5, or 3. Third slice was 7 minus 5, or 2. And we add all these up, and we would get the consumer surplus for eating 7 slices of pizza. Visually, I showed you it's this. He went out 1. So this block right here, the area of this block, he ate 1 slice of pizza, his first slice. That's the horizontal. His vertical distance is 9 minus 5. That block, the shaded region, measures the consumer surplus of the first slice. This block is the second slice. This block is the third slice, fourth slice, okay, etc., etc. All right. So we would have these like staircase consumer surpluses. Okay. However, it is quite possible. All right. Let me draw this again. Okay. It is quite possible that you could eat fractional slices of pizza. Okay. Here, if we don't allow for the consumption of fractional slices of pizza, our demand curve will be staircase shaped. But we generally play with these linear, continuous demand curves. What that implies is that this consumer is able to eat half a slice of pizza. He's able to buy a quarter of a slice of pizza, a third of a slice, etc., etc. And if you're allowed to buy a quarter of a slice of pizza, you could see that that the distance, the horizontal distance, gets shorter and shorter, right? And this part right here, these triangles that we are not measuring, they disappear. When you are allowed to buy a quarter of a slice of pizza, the consumer surplus becomes the area that's between the demand curve and the price paid. Okay, specifically, if you're allowed to eat continuous fractional pizza slices, your consumer surplus becomes this shaded region right here. Okay. And then the area, consumer surplus is the area of the shaded region, which is 1/2 base times height. Base is between 0 and say 7, and height, so it's 7, and height is 10 minus 5, or 5. Okay, that would be consumer surplus. All right, we're going to use the same type of logic to discuss consumer surplus for market demand curve. Let's talk about that next. Okay, with market demand curve, the mechanics are identical, but the logic, the intuition is slightly different. Here's price of pizza, quantity of pizza, the demand curve. All right. Okay, this is the market demand. So this is the demand for pizza in Costa Mesa or whatever city we could think of. All right. Here, the first tranche of people entering, let's say 100 people, they will eat pizza if the price isn't $10, but say $8. They come in and they buy pizza. The next tranche of people, group of people, doesn't have to be another 100, could be like 150 people now. They come in when the price of pizza is like $6. Okay. And the next grouping of people, okay, they come in when the price of pizza is $6.50, whatever. But that's not how people buy pizza in random cities around the United States. There's a menu. Okay, when you go to the pizza store has a menu and they say pizza is $5 each, and everybody could buy as many pizzas they want at $5 each. Okay, say a total of, And let's say here, given this market demand curve at $5 a slice, 700 slices are purchased. Okay. So the consumer surplus here, using the market demand curve, the total consumer surplus for 700 slices of pizza, okay, is equal to the consumer surplus for the first group, the consumer surplus for the second group, third group, etc., etc. All right, so let's talk about this. Okay, consumer surplus for the first group plus consumer surplus for the second group plus consumer surplus. Let's do the first three groups because I only have three right here for the first three groups. All right. For the first group, they bought 100 slices of pizza. Okay. Right. And they were willing to pay 8, but they ended up paying 5. So the consumer surplus is the area of this rectangle, and that is base times height. That's how you find the area of the rectangle. And the base is 100 times height is 8 minus 5, or 3. So it'd be 300. The next group, we'll use a different color. Their consumer surplus is that group bought 150 slices because we went from 100 to 250, so it's plus 150. These people were willing to pay $6. Wait, 656. Uh-oh, this is wrong. 675. They're willing to pay $6.75 a slice, but they end up paying 5. So the horizontal distance for base, so their consumer surplus is the area of this box, base times height. The height is 1.75. The base is 150. Give me a calculator. Hold on. And that is 1.75 times 150 is 262.5. The third tranche of people entered, they ended up buying again 250 to 500. That's 250 slices. Okay. They ended up buying 250 slices. They're willing to pay $6.50, but they ended up paying 5. So they made out by $1.50 per slice. So their consumer surplus is this, base times height. Base is 250 times height is the $1.50. They're willing to pay $6.50. They ended up paying 5. So they kind of made a quote unquote profit of $1.50 per slice. That's the consumer surplus. They're like profit. So 150 times $1.50 times 250 is $3.75. So the total consumer surplus for these 4 groups, first group, second group, third group, fourth group, is this number here. You add up these numbers right here. Okay, just like for consumers, the individual demand curve, if we allow for, say, purchases of individual level pizzas, in this case, it would be, let's break up the groups into small, tiny, infinitesimal groups that are allowed to buy very small fractions. That will allow us to use the continuous demand curve, and our consumer surplus would include these triangles right here. Okay. And then what we would have to do is the total consumer surplus for 700 pizza is equal to the area of this triangle, which is 1/2 base times height, which is equals 1/2 base, which is 700, times height, which is 10 minus 5, or 5. Okay. So again, if we're allowed to buy fractional amounts of pizza, then consumer surplus becomes the area of this triangle. If we're not allowed to buy fractional amounts of pizza, then we would have to give you the groupings of pizza that are purchased. Okay. And we would have demand curves that are staircase shaped. All right, let's clear this and move on. Okay. Changes in price. A change in price affects consumer surplus. So let's draw this. Here's the demand curve. Here's quantity of pizza. Here's price of pizza. That's the demand curve. And let's suppose the price is P1 and people are buying Q1. Consumer surplus would be marked by, say, A. That's the area of this triangle right here. All right. Suppose price fell to P2. Well, we got consumers buying more pizza, goes out to Q2. And then consumer surplus will be A plus B plus C. Okay. We could break up B and C, and what we could do is tell you who got B and who got C. Okay. So let me write this out. B is the additional consumer surplus from those consumers willing to purchase at P1. Okay. B, certain customer were more than happy to pay this higher price and buy Q1 amounts. They were happy to get A as their consumer surplus. When they went to the store and they saw the price fall, they get more consumer surplus. They get additional kind of happiness. And that's measured by B. Okay, that's what they get. C is the consumer surplus gained by new customers that would not buy at that original price of P1. Okay. So when the price falls to P2, more people enter, and then they end up buying the difference between Q2 to Q1. So this amount right here is purchased by, say, new entrants into the marketplace. They would not buy pizza at this price. But when the price falls, yeah, I could buy pizza. And they come in. C is the consumer surplus of these new people who only buy pizza because the price fell. Okay. All right, that's my end of my discussion of consumer surplus. Now we're going to talk about producer surplus. Basically, this is opposite day of consumer surplus. All right, producer surplus, I'm going to use PS for producer surplus. PS, or producer surplus, is defined as the amount a seller is paid for a good or service minus the seller's cost of providing it. Okay. Okay, the amount a seller is paid for something. Well, that's just the price. That's easy. Okay. The amount seller receives is easy. The seller's cost. Okay, so what are we going to use for the seller's cost? What we are going to use is the seller's supply curve. Why? Because remember the supply curve in chapter 14, we learned, when we learned about perfect competition, we learned that the supply curve is equal to the marginal cost curve. That's why we're going to use the supply curve as the seller's cost. Okay? And we will go through this for both the individual supply and the market supply curve to show you why it makes sense to use the supply curve. Okay? So let's do this now. Here's the individual supply curve. There's the price of pizza, quantity of pizza. There's the supply curve for pizza. All right. That first slice of pizza, whatever this company, Domino's, is more than happy to sell it at 50 cents. Why? Because that's how much it costs them to make it. Remember, that first slice, the supply curve is the marginal cost curve. Remember what the marginal cost curve is. It's a change in total cost divided by change in quantity. I change quantity by 1 unit. This is the additional cost to make this 1 unit. This is the cost basically to make this 1 extra unit. Okay? So that's why we're going to use it as the cost to make 1 unit. All right. How about for the second slice? I don't know, 75 cents. I'm more than willing to sell it for 75 cents. The third slice? $1. Cost me $1 to make it. I'm more than willing to sell it for $1. But that's not how Pizza Hut sells pizza. They have a menu. And it's $5 each. They sell pizza at $5 each. And here, if the going rate is $5 a slice of pizza, this company is going to sell, I don't know, 7 slices of pizza. Okay? Because the world operates in this manner, where there's a menu and the company could sell 7 slices at $5 each, for that first slice of pizza, the company was more than happy to sell that first slice at 50 cents a slice, at 50 cents. But he ended up selling it for $5. So this company basically made a profit or producer surplus of $5 minus the cost of 50 cents. Okay? So this is the vertical distance here is $4.50. And how much? And that was per pizza. And he sold 1 pizza. So the producer surplus is the area of this rectangle right here. Okay. So the producer surplus for the first slice is 5 minus 50 cents, or 450, times 1. Producer surplus for the second slice is, well, the company was more than happy to sell it at 75 cents, but he again sold it for $5. So he made $4.25. Okay, $4.25. And how many pizzas did he sell with this type of producer surplus? Only 1. So again, this rectangle is the producer's surplus for his second slice of pizza. Well, let's do the last one, producer surplus for the third slice. Let's do a third one. Again, he was willing to sell it for $1. He ended up selling it for $5. He made 5 minus 1, which is $4 per slice. But he only sold one at that quote unquote profit or producer surplus. Okay, so again, his producer surplus for that third slice of pizza is the area of this rectangle. We could do it again for the fourth slice, the fifth slice, etc., etc. Okay, so the total producer surplus of selling of for selling 7 slices is equal to PS1 plus PS2 plus PS3 all the way to PS7. Okay. And what we would have to do is basically then visually, okay, we did it mathematically here. Visually, what we do is add up the area of this rectangle plus this rectangle plus this rectangle, this one, and this one. Okay. And that's how you get the total producer surplus. Now, just like for demand, that means our supply curve is staircase shaped like this. Okay. Normally, we operate with a smooth, continuous line supply curve. That implies that we could sell fractional amounts of pizza. If we say this seller can sell fractional amounts of pizza, the implication on producer surplus is that these triangles that we don't include in calculating producer surplus, they would get included. Okay, like how? Because fractional amounts allows us to calculate even smaller and smaller and smaller rectangles. And you could see these rectangles will eventually get included once these producers, once you are able to sell even smaller fractional amounts of pizza. Okay, so then the producer surplus for if you're allowed to sell any fractional amounts of pizza is calculated as 1/2 base times height. 1/2 base is 0 to 7 or just 7, and height is 5, and then we'd have to know what this number is here. Let's put 25 cents. So it's 5 minus 25 or 4.75. And whatever we calculate here, that is the producer surplus for a continuous supply curve. Okay. Now let's talk about producer surplus and why it makes sense to use the supply curve as the cost curve at a market level. Let's do it now. Quantity of pizza, price of pizza, market for pizza. It's a supply curve. Okay. The first group of pizza sellers enter, and they're more than happy to sell pizza at 25 cents a slice. Okay, let's say at I don't know, 10 cents a slice, no one sells pizza. The next group enters, and they're willing to sell 150 slices, so 50 slices for them at 75 cents a slice. And the next group enters, and they will sell 150 slices because it went from 150 to 300 at $1 a slice. But that's not how, again, sellers sell pizza. What we are assuming is there's a menu. There's a prevailing price for pizza. Let's say $5 a slice. Okay. And in this market, 1,000 slices are sold. Now, if we wanted to calculate producer surplus, we would have to calculate the producer surplus for each group of sellers. Okay. The first group came in plus 100, right? They're more than happy to sell pizza at 25 cents a slice. They sold it at $5 a slice. So they made, so producer surplus for the first group, they made $4.75 per slice. And how many slices did they sell? 100. Okay, so that is their producer surplus, or the area of this rectangle. The second group, producer surplus for the second group, they were more than happy to sell pizza at 75 cents a slice. They ended up selling pizza at $5 a slice. So they made like a profit of $4.25 per slice. And how many slices did the second group sell? 50. Okay. And that would be the area of this rectangle. The third group is the area of this rectangle. Fourth group is the area of this rectangle. Fifth group is like this. Sixth group, seventh group. So if we calculate the total producer's surplus in this market for selling 1,000 slices, it would be this rectangle here, plus this rectangle here, plus the area of this rectangle here, area of this rectangle, this rectangle, this rectangle, and that rectangle. Specifically, we would not include this triangle, this triangle, this triangle, this triangle, these triangles into producer surplus. The only way we include the area of these triangles into producer surplus if we allow for very tiny groups that sell crumbs of pizza, ever so small bits and pieces of pizza. If that is allowed, producer surplus becomes the area of this triangle. Again, it's producer surplus is equal to 1/2 base times height. 1/2 base is 1,000 times height, which is $5 minus 10 cents, or $4.90. Okay. Okay. Let's move on. Just like for the demand curve, the producer surplus is affected by the change in prices. Okay. Producer surplus is affected by the change in price. Here's quantity of pizza, price of pizza, supply curve. Here's P1, that's the price right now. This is how much is sold, Q1, and A is producer surplus. Suppose we have a change in price and the price goes up to P2. Okay. And they sell now Q2. Now this gain right here, we could break that into B and C. B is earned by those that were already more than happy to sell pizza at P1. Okay, so let me write that out. Okay. They're more than happy to sell pizza at P1. Price went up for some reason, and they got a surprise amount of producer surplus, like profit, because they're able to sell at P2 instead of P1. Well, what about C? C is producer surplus for new sellers not willing to sell at P1, but now sell at P2. These people were not going to sell pizza at P1. It was too low. But when the price of pizza went up, new people came in and started selling pizza. And those new people that came in and started selling pizza gets C. Okay. All right, let's clear this and go to market efficiency. And total surplus. All right, the next topic here is to talk about total surplus and market efficiency. All right. Okay. So the goal is to use surpluses, consumer surplus, producer surplus, stuff like that, to measure efficiency. Well, first, before I do that, I got to introduce you to something called total surplus. Okay, what is total surplus? It's consumer surplus plus producer surplus. All right. And then I got to define to you what is efficiency. The allocating of resources with minimal waste. Okay. All right. So I introduced two different things. The first thing I'm going to do is just draw to you what visually consumer surplus looks like. Here's price, quantity of pizza, price of pizza. Let's just make this the market for pizza. This is the demand curve. Okay, demand curve. This is the supply curve. This is happy-go-lucky equilibrium A. This is the prevailing wage price, P star, and the amount being bought and sold, Q star. Consumer surplus is the area below the demand curve or the willingness to pay above the price paid or P star. So consumer surplus is this upper triangle. Producer surplus, by definition, is the amount received by the seller or the price minus the cost to seller, which we use the marginal cost curve, or in this case, the supply curve, right? And that's producer surplus. Remember, supply curve is equal to the marginal cost curve. Total surplus is this big fat triangle that comprise of, okay, consumer surplus plus producer surplus. All right. So how do you measure total surplus? Well, you could do base times height, okay, of this triangle, assuming both supply and demand are linear or lines, or you could just calculate consumer surplus and add it to producer surplus. It should be identical. All right. Before we move on, I want to introduce something that I'm going to talk about and use this term throughout the next several chapters. And it's called benevolent social planner. Benevolent social planner. Sometimes I use the benevolent planner. Sometimes I use social planner. Sometimes I use the correct full word of benevolent social planner. What is benevolent social planner? It's an all-knowing, all-powerful, well-intended dictator or god that wants to maximize the economic well-being of the society. And how do they do that? By maximizing, total surplus. Okay. Basically, this is the tool, benevolent social planner is something, this tool or something, this concept that economists use to study policies, to study different markets and see, well, what would a benevolent planner do in this situation? How would they maximize total surplus if we see X or Y or Z? Okay, so we're going to use that a lot. Okay, so let's look at this market equilibrium and see if a benevolent planner could maximize total surplus by changing or manipulating anything. Okay. All right, let's do this. First, I'm going to talk about it one way, and then I'm going to talk about it another way. Let's use these formulas we learned up here and talk about how the equilibrium is efficient using these formulas. And then I'm going to talk about it a different way. Okay. All right, so we have total surplus that is equal to consumer surplus plus producer surplus. Consumer surplus is value to the buyer minus amount paid or price, plus producer surplus is amount received by the seller or price, okay, minus cost to seller. Here, total surplus, we could rewrite this as this minus that. It's value to the buyer minus cost to seller. Okay. At this point A, exactly at that point A, not from 0 to Q star, but at that point A, when we're producing Q star, okay, the total surplus, which is the vertical distance between the value to the buyer or the demand curve and cost to the seller or supply curve, that vertical distance is equal to 0. Value to the buyer minus cost to seller. Okay. We could see at exactly in equilibrium, value to buyer equals cost to seller. In equilibrium, society in this marketplace for pizza, society's value, those who buy pizza, their value exactly equals to the cost to the seller. We do not spend more resources. We use exactly the resources necessary to produce pizza. That is exactly equal to the value. Okay, there is no waste here. Okay? Let's look at it a different way. Hopefully that made sense, but we're going to look at it a different way. Let me clear this. Quantity of pizza, price of pizza, market for pizza, demand and supply, happy-go-lucky equilibrium A, P star, Q star. Okay. We know again this big triangle, that is total surplus. This is consumer surplus, producer surplus, big triangle's total surplus. All right, let's see what happens. Can a benevolent planner comes here and they look at this situation. Can they tweak quantity to make total surplus increase? Well, let's see this. Let's suppose they tweak it by reducing quantity slightly to here. If they did that, total surplus would be reduced by this amount here. Total consumer surplus would be this. Producer surplus would be this. And we would have to chop this out. So if a benevolent planner reduced quantity slightly from the equilibrium amount to Q1, we would have a reduction, total surplus would fall. Okay, let's try this again using if the benevolent planner tried to increase production and increase quantity. So we go happy-go-lucky equilibrium A, consumer surplus, producer surplus, P star, Q star. Let's suppose benevolent planner is like, okay, I know if I decrease quantity, total surplus would fall. What about if I increase quantity to Q2? Okay. Well, I got consumer surplus here, producer surplus here, and since I increase quantity, I have this right here. Okay. Well, let's see what is this equal to? This is, if I move out the value remember total surplus is equal to value minus cost, value to buyer minus cost to seller. So if I went from Q star to Q2, values down here, but cost is up here. So this right here, this triangle, we don't add it to total surplus, we subtract it. Again, when you go from Q star to Q2, we have this triangle, but that actually gets subtracted from total surplus. So we lose total surplus. Again, total surplus falls. Q star and P star provides this market equilibrium of Q star and P star. This market equilibrium provides the maximum total surplus. And we also saw that was an efficient outcome because the costs that are used, the resources, the value of those resources, or the cost of those resources, exactly equal to the value to the buyer. Okay. So the conclusion that we wanted to get from these graphs or this analysis is the forces of supply and demand allocate resources efficiently. We are done with this chapter. Have a good day.